All right, for this problem, we're asked to find the exact value of the sine of 11 pi over 12. So to make this a little easier to work with, let's change this angle from radians to degrees. So we'll do that by multiplying 11 pi over 12 times 180 over pi. So if we do that, the pi's will divide to 1, and 12 goes into 180 15 times. And 11 times 15 is 165. So this is equal to the sine of 165 degrees. All right, now 165 degrees isn't on our unit circle. So we're going to write this as the sine of 45 degrees plus 120 degrees. Because 45 degrees and 120 degrees both are on our unit circle. And we can use our sum identity for sine, which is sine of a plus b is equal to sine of a times the cosine of b plus the cosine of a times the sine of b. So this is going to be sine of 45 degrees times the cosine of 120 degrees plus the cosine of 45 degrees times the sine of 120 degrees. All right, so sine of 45 degrees and 120 degrees are both on our unit circle. So let's fill these in. The sine of 45 degrees is square root of 2 over 2, and the cosine of 120 is negative 1/2. So this is the square root of 2 over 2 times negative 1/2. Plus cosine of 45 degrees is also square root of 2 over 2. And the sine of 120 degrees is square root of 3 over 2. All right, now to multiply these fractions, we just multiply the numerators, then multiply the denominators. So negative 2 times, or square root of 2 times negative 1 is negative square root of 2. Over 2 times 2 is 4. And then here, the square root of 2 times the square root of 3 is the square root of 6. And again, in the denominator, we're going to get 4. So now we have a common denominator here. We can write this as negative square root of 2 plus square root of 6, or square root of 6 minus 2, minus the square root of 2, divided by 4. And that's going to be our answer.